Okay, guys, so this is section 3.5. This section is all about word problems and application problems for exponential functions and log functions. And a big idea we talk about in this section is half-life. Okay, half-life is the length of time. Half-life is a time. It's the length of time it takes for some substance to reduce to half of its original amount. So it says the half-life of a certain tranquilizer in the bloodstream is 24 hours. Okay, that is how long it takes for any amount of the substance to reduce to half of the amount you start with. The question's asking how long will it take for the drug to decay to 85% of the original dosage. So if it takes 24 hours to get down to 50% of the original dosage, it should be less time for 85%, but we don't know how much. So it says use the exponential decay model to solve. We're going to have to come up with our own model first before we can figure out how long it'll take to reduce to 85%. So here's how we set this up. We start with our model. Okay, so let's think about what they gave us and what they didn't give us. They did not give us an initial amount. This is our initial amount, how much we start with. They didn't tell us. That's because it doesn't matter. Okay, we don't necessarily need an initial amount. So we're just going to keep using A naught for that. They didn't give us our decay rate, so we don't know K. But they did tell us in 24 hours, we will end up with half of whatever we started with. But again, we don't know what we started with. So the way we write this is the amount we started with divided by 2. Okay, if A naught represents the amount we started with, then what we end up with after 24 hours is whatever we started with divided by 2. Okay, so A naught represents what we started with. So A naught divided by 2 is half of what we started with. Another way people like to write this, some people prefer to write it half A naught, and that's fine too. That doesn't matter. And I'll make this 24K. Okay, so we know that after 24 hours, we end up with half of our original amount. We're going to use this to solve for K. Okay, we're going to solve for K. That's what we're looking for first. That's not what it's asking for, but that's what we need. So the trick to this, since I have A naught times e to the 24K, I'm going to divide by A naught on both sides. If they'd given us a starting amount, like say we started with 1,000 grams or whatever, we would have divided by that starting amount even if they had given it to us. Like this would be our first step, whether this was a number or a variable. And what's nice is it just ends up canceling out on both sides, right? So we end up with half on this side equals e to the 24K. All right, so now trying to solve for K, since this is base E, I'm going to use natural log. So if I do the natural log on both sides, the natural log and the E are inverses, so I'm left with 24K equals natural log of a half. Okay, and then I divide by 24 to solve for K. Let me pull up my calculator. natural log of 1/2 divided by 24 means k equals negative 0.02888. And it's negative because this is decaying, right? That makes sense. So my model specific to this kind of tranquilizer is going to have this value of k. So we still haven't answered the question that they're asking us to answer, but we have figured out what k is so that we have a model specific to the problem. So now let's go back to what they're asking us. They want to know how long, so they're looking for t, how long will it take for the drug to decay to 85% of the original. Again, they didn't give us an original. We don't know how much we started with, but we know that if we started with some amount, A0, we want to end up with 85% of our original, so 85% of A0. This is the same setup that we used over here. It's the same concept, except now we know what K is and we're looking for T. Okay, so I'm going to do the same things I did. I'm going to divide by that A0. So I have 0.85 equals e to this long decimal, and then t. Same as before, since it's base e, I'm going to take the natural log of both sides. Those will cancel. I have the natural log of 0.85 equals negative 0.02888 t. So to get t by itself, I divide by this obnoxious decimal. It's so long. Okay, so I'm essentially, to get t, I need to type in this thing. Now, I'm going to show you the same thing I showed you in the last video. I don't want to chop this up. I don't want to just make it 0.02 or 0.03 and leave it. I need to use as many decimals as I can for accuracy. But I also don't want to take the time to type all of that. So I'm going to do natural log of 0.85 divided by the answer I just had. So I use the answer button. And that way it uses the whole answer, but I didn't have to sit there and retype the whole thing. So this says t equals 5.6 hours. And I'm rounding to 1 decimal place because this says to round to 1 decimal place. Okay, so 5.6 hours. If it takes 24 hours to reduce to half, it only takes 5.6 hours to reduce to 85%. Yay! Okay, so notice if you had started rounding in the middle of your problem, whoops, let's say you rounded this long decimal to negative 0.03. Right, let's say you rounded this. Let's see how different our answer would have been. Whoa, way different, right? We would have had 5.4 instead of 5.6. You cannot just round things whenever you want to. You have to leave the answers whole until the end of the problem. You do not round until the end of the problem because it makes a big difference in our math. Okay. I think that's it for this one. A lot of these half-life problems work the same way, where you have to solve for k first, and then you go through and you answer whatever question they're wanting you to answer. Okay? But you need k to have an equation to work off of. So if you have any questions, let me know. If there's anything else in this section that you need help with, you can post it in the forums or send me an email. All right, bye.